Hello everyone, let's go through next important question. If the ratio of the sum of the first n terms of two APs is 7n plus 1 is to 4n plus 27, then find the ratio of their ninth terms. Okay, here see what is given. There are two APs. Okay, so let A1 be the first term of first AP and D1 be the common difference of first AP. Okay, and let A2 be the first term of second AP and D2 be the common difference of second AP. Okay, and it is given that the ratio of the sum of the first n terms of two APs is 7n plus 1 is to 4n plus 27. That is, it is given that Sn divided by Sn dash. Let's take here n is same. Okay, so let's take Sn divided by Sn dash. That is, sum of first n terms of the first AP is Sn and sum of the first n terms of the second AP is Sn dash. Okay, its ratio is given 7n plus 1 divided by 4n plus 27. Okay, after that, see what is Sn? Here, that is sum of first n terms of first AP. That is n by 2. N is n itself because it is given that sum of first n terms. Okay, in both AP, sum of first n terms. So, n is n itself. Okay, n by 2. Here, in both n is same. Okay, n by 2, 2a. 2 into first term, that is 2a1 plus n minus 1 into d1, common difference of first AP. Divided by, here also n by 2. 2 into first term, that is 2 into a2, first term of second AP, plus n minus 1 into d2, common difference of second AP d2. That is equal to 7n plus 1 divided by 4n plus 27. See, here it is cancelled. Right? Now we have got 2a1 plus n minus 1 into d1 divided by 2a2 plus n minus 1 into d2, that is equal to 7n plus 1 divided by 4n plus 27. Okay, now what we have to find? We have to find the ratio of their ninth terms. That is ratio of ninth term. How can we write ninth term? That is, if a is the first term and d is the common difference, then we know that ninth term is a plus 8d. Right? So here we have to find the ratio, that is ninth term of the first AP, that is a1 plus 8d1 divided by a2 plus 8d2. That we have to find. Okay. Now here let's make in this form, this one. Okay. See here coefficient of a1 is 1, here 2. Right? So let's make it 1 by dividing numerator and denominator by 2. Okay, see here we will get, divide this numerator and denominator by 2. So we will get a1 plus, this will be here, that is n minus 1 by 2 into d1 divided by a2 plus n minus 1 divided by 2 into d2. That is equal to 7n plus 1 divided by 4n plus 27. Okay, now see, here a1 plus n minus 1 by 2 into d1, a2 plus n minus 2 into d2. We have to find a1 plus 8d1 divided by a2 plus 8d2. Now let's see, if n minus 1 divided by 2 is equal to 8, then what is the value of n? Okay, that is n minus 1 divided by 2 is equal to 8. That implies n is equal to, n minus 1 is equal to 16. This implies n is equal to 17. See, here we have got n is equal to 17. If n is equal to 17, it will be a1 plus 8d1 divided by a2 plus 8d2. Now here we have to substitute n is equal to 17. Right? See, substitute n is equal to 17 here. So here we will get a1 plus 8d1 divided by a2 plus 8d2, that is equal to, substitute n is equal to 17, 7 into 17 plus 1 divided by 4 into 17 plus 27. That is equal to 7 sevens are 49, 7 ones are 7, 7 4 11 plus 1 divided by 28, 68, right? 68 plus 27. Sorry. 4 sevens are 28. Okay, 68. That is equal to 120 divided by 80, 95, right? That is equal to 5 twos are 10, 5 fours are 20, 5 ones are 5 nines. Okay, so here we have got the ratio of ninth terms. Ratio of ninth terms is, that is a plus 8d1 divided by a2 plus 8d2 is equal to 24 divided by 19. Required ratio is 24 is to 19. In an AP, the sum of three consecutive terms is 24 and the sum of their squares is 194. Find the numbers. See, you have to remember, see, if in your question, if there are three consecutive numbers, okay, if it is given sum of three consecutive terms, then you have to take the three terms a minus d plus d, a plus d, a plus d. Okay. See, and if there are four terms, then you have to take a minus 3d plus 2d, a minus d plus 2d, a plus d, a plus d plus 2d, a plus 3d. Okay, remember this one. So here it is given that sum of three consecutive terms is 24 and the sum of their squares is 194. We have to find these numbers. Okay. So here we have to take a minus d, a plus d. Why we are taking this one? See, when we taking this one, when these are added, see this d will be cancelled so that we can find the value of a. Okay. So here it is given that sum of three consecutive terms is 24. So we have taken three consecutive terms a minus d, a plus d. That is a minus d is the common difference. Okay. A minus d plus c plus d, a plus d, a plus d. Okay. See here. So it is given a minus d plus a plus d is equal to 24. Okay. That is sum of these terms is 24. Now see d cancelled. 3a is equal to 24. That implies a is equal to 8. Okay. Now it is given that sum of their squares is 194. That is a minus d whole square plus a square plus a plus b whole square is equal to 194. Now what is its square? A square minus 2ad plus b square plus a square plus, expand this, a square plus 2ad plus b square is equal to 194. Here minus 2ad plus 2ad cancelled. Now how many a square? 3a square, right? 3a square plus 2d square is equal to 194. Now let's substitute value of a. Okay, that is 3 into 8 square, 8 into 8 plus 2d square is equal to 194. That is 24 into 8 plus 2d square is equal to 194. See here, 32, 8 2s are 16, 90. 192 plus 2d square is equal to 194. So 2d square is equal to 194 minus 192, that is 2. So d square, this implies d square is equal to 1. D square is equal to 1. That implies d is equal to either 1 or minus 1, right? D is equal to plus or minus 1. Okay, now we have to find the numbers. If d is equal to, see, when d is equal to 1, what is the number? A minus d, right? That is 8 minus 1, 7, right? Next, 8. Next, 1, 9. Okay. When D is equal to minus 1, what are the numbers? See, A is equal to 8. 8 minus minus 1, that is 9. Okay. Next is 8. Next is A plus D, that is A plus minus 1, that is 7. Okay. So, these are the numbers. 7, 8, 9. Look at this question. The sum of first two terms of an arithmetic progression is same as the sum of the first 7 terms of the same arithmetic progression. Can such an arithmetic progression exist? Justify your answer. Okay. If sum of first two terms of the arithmetic progression and sum of the first 7 terms of the AP are equal, then we have to check such arithmetic progression exists or not. Let's check. It is given that sum of first two terms of an AP and sum of first 7 terms of an AP are equal. Okay. That is S2 is equal to S7. Okay. According to the question, we can write S2 is equal to S7. Now, what is S2? Sum of first two terms. Okay. Here it is about only one AP. That is same AP. Okay. That is sum of first two terms and sum of the first 7 terms of the same AP. Okay. Are equal. Now, S2 is equal to 2 by 2 into 2A plus n minus 1. N is 2 here. That is 2 minus 1 D. Okay. 1 into D is equal to, here n is 7. 7 by 2. 2 into A plus 7 minus 1, 6D. Here 2 cancelled. Okay, 2A plus D is equal to, here 2 is common. We can take 2 outside and cancel with this. Okay, that is 7 into, here it will be A plus 7 into 3, 21D. Okay, we have taken 2 and cancelled. Now, here after that 2A plus D, take all these terms left side. Minus 7A minus 21D is equal to 0. 2A minus 7A minus 5A. D minus 21, that is minus 20D is equal to 0. Here minus 5 is common. We can take it out and take to right side. Okay, cancel. Minus 5 into A plus 4D is equal to 0. That is A plus 4D is equal to 0. See, we have got A plus 4D is equal to 0. What is A plus 4D? A plus 4D is nothing but fifth term, right? That is A5. A5 is equal to 0. So, it can be possible, right? So, if A plus, that is fifth term is 0, then sum of first two terms and sum of first 7 terms of an AP are equal. Okay? So, it can be possible and we can write such an arithmetic exists. Arithmetic progression exists. This implies arithmetic progression exists. The sum of first n terms of 3 APs are S1, S2 and S3. The first term of each AP is unity and their common differences are 1, 2 and 3 respectively. Prove that S1 plus S3 is equal to 2S2. Okay, very simple question. Here it is given that there are three APs. Okay, 3 arithmetic progression. And it is given that sum of first n terms of first AP is S1. Okay, and sum of first n terms of second AP is S2. And sum of first n terms of third AP is S3. Okay, and it is given that first term of each AP is unity, that is 1, right? So here let's take A1 be the first term of first AP and A2 be the first term of second AP and A3 be the first term of third AP. So here these are equal to 1. Okay, and let's take and it is given D1 is equal to 1, D2 is equal to 2, D3 is equal to 3. That is common difference of first AP 1, common difference of second AP 2, common difference of third AP is 3. Okay, now it is given that, see, here we have to prove S1 plus S3 is equal to 2S2. So first of all, let's find the LHS, that is S1 plus S3. Okay, so S1 plus S3. What is S1? Sum of first n terms of first AP. Okay, first n terms, that is n. Okay, how many terms? N terms. So n by 2 into 2 into first term, that is 2 into 1, plus n minus 1 into D, that is common difference of first AP, that is 1. Okay, plus S3. S3 is the sum of first n terms of third AP. Okay, S3 is the sum of first n terms of, here it is given that S3 is the sum of first n terms of third AP. That is n by 2, 2 into first term, that is 1 itself. Okay, 1 plus n minus 1 into common difference of third AP is 3. It is given here. Okay, that is 3. That is equal to, n by 2 is common, we can take it out. N by 2 into, here 2 into 1 2 plus n minus 1. N minus 1. Okay, plus, no need of bracket because we have taken n by 2 outside. Okay, 2 into 1 2 plus 3n minus 3. That is equal to n by 2. Here 3n plus n, 4n, and 2 minus 1, 2 plus 2, 4, minus 1, minus 3, minus 4. So 4 minus 4, 0. So it is 0. That is equal to, see, n by 2 into 4n, that is equal to, here 2 cancelled, right? So here 2 cancelled, then 2n square. Okay, we have got 2n square. LHS is 2n square. Now next we will find RHS. Okay, we have to prove LHS is equal to RHS. Okay, let's find RHS, that is 2s2. 2s2. Let's find first s2. Okay, what is s2? Sum of first n terms of second AP. That is n by 2 into 2 into first term of AP. See here, first term of all the AP are same, right? That is 1. So 2 into 1 plus n minus 1 into the common difference of second AP. That is 2. That is equal to n by 2 into, here 2 plus 2n minus 2. That is equal to 2 minus 2 cancelled. So and this 2 will be cancelled. So here we will get n square. S2 is equal to n square. What is 2s2? RHS is 2s2, right? 2s2 is equal to 2n square. Okay, that is equal to, here it is LHS. Okay, it is RHS. RHS is equal to this one. So it is equal to LHS. Hence it is proved. Bricks are stacked in the following manner: 30 bricks in the bottom row, 29 bricks in the next row, 28 bricks in the row next to it, and so on. In how many rows 360 bricks are placed and how many bricks are there in the top row? See, here the bricks are stacked in each row form a sequence. How? See, 30 bricks in the bottom row, okay, and 29 in the next, and 28 in the next row, okay. So here that is 30 in the bottom row, then 29 bricks in the next row, and 28, then 27, etc. There are total 360 bricks. Okay. So what we have to find? In how many rows 360 bricks are placed? Means here we have to find how many, that is value of n, right? That is, here we have to find the how many bricks are there in the top row. Means, see, here we will consider this bottom row as the first term, okay, and we have to find the last term, that is nth term, which is the top row. Okay, if we consider this as the bottom row, then last term as the top row, right? So here we have to find what is the nth term, that is last term. Okay, and we have to find the value of n, and it is given sum of the first n terms, that is given. Okay, now here we will find, that is sum Sn. Okay, we don't know what is the value of n, that is how many rows are there. Okay, and we have to find the number of bricks in the top row, that is the last term. Okay, now Sn is equal to, here see, first of all, here we consider this as the first term. Okay, bottom row is the first term. So A is equal to 30 and D is equal to 29 minus 30, that is minus 1. Okay, it's an AP. Now Sn is equal to 360. Right, there are total 360. Now what is Sn? Sn is equal to, that is n by 2, 2a, 2 into a, that is 30, plus n minus 1 into d is minus 1 into minus 1 is equal to 360. Okay, that implies, take this 2 here. Okay, so n into 60 minus 1 into n minus n plus 1 is equal to 360. Okay, then that implies here minus n square plus 61 minus, sorry, here we have taken 2 here, right? So it will be 720. Then minus 720 is equal to 0. Okay, now let's take all these terms right side, so that it will be plus n square. Okay, so n square minus, or take minus outside and take it here. Okay, so minus 61 plus 720 is equal to 0. Now we have got a quadratic equation. Now we will find the value of n by quadratic formula. Okay, that is n is equal to, here a is equal to 1, b is equal to, sorry, it is minus 61 n. Okay, okay, minus 61 n, b is equal to minus 61, c is equal to 720. N is equal to minus b, that is minus 61. Okay, I will write the formula, minus b plus or minus root of b square minus 4ac divided by 2a. That is equal to minus of minus 61, 61 plus square root of b square, 61 square. What is the square of 61? Okay, 6, 36. 1, 12, 7, 3, right? 6 ones are 6, 6 6 are 36. Okay, that is 3, 7, 2, 1 minus 4 into A is 1 into C, that is 720 divided by 2 into 1. Okay, 61 plus square root of, it is 3, 7, 2, 1 minus 0, 4 2s are 8, 4 7s are 28 divided by 2. 3, 7, 2, 1 minus 2, 8, 8, 0. 1, 4, 2, sorry, 8, right? We have taken this one. So 16 minus 8, that is 841. Okay, that is equal to 61 plus square root of 841 divided by 2. See, what is the square root of 841? See, we know that square root of 900 is 30. Okay, square root of 900 is 30. Then it is 841, it is less than 900, therefore it must be less than 30. Okay, square root of 841 must be less than 30. And in less than 30, here unit number, that is first number is 1. So it may be 29, 9 9s are 81, right? So let's take 29. 29 into 29, 81, 9 2s are 18, 26, 2 8s, 2 9s are 18, 2 2s are 4, 5, 1, 14, yes, 841. Okay, now 61 plus or minus square root of 841 is, that is 29 divided by 2. Okay, then here n is equal to, we have got two values, right? N is equal to 1 is 61 plus 29 divided by 2 or 61 minus 29 divided by 2, right? So here say it is 680, 90, right? 90 divided by 2, 45. Or here 61 minus 29 is 32, right? 32 divided by 2, 32 divided by 2, that is 16. Okay. So we have got two values, n is equal to 45 or 16. Okay. Now let's find the, yes, what we have to find? Yes, nth term. Right? We have got the value of n, 45 or 16. Let's find the nth term. Okay, nth term is here. That is last term. That is how many bricks are there in the top row. Okay, that is the nth term. Okay, let's find. I will find it here. That is A 45. If n is equal to 45, because we have got two values for n. Okay, so first we will take n is equal to 45. That is A 45 is equal to, now A 45 is equal to A plus, what is A? First term, 30 plus n minus 1, that is 44 into d minus 1. Okay, that is equal to 30 minus 44. Okay, that is equal to minus 14. See, we have got 45th term is minus 14. See, here actually what is the terms? Here number of bricks. So number of bricks cannot be negative. It must be positive, right? So here minus 14 is not possible. Okay, A 45 is equal to minus 14. That means last term is minus 14 is not possible, because the nth term is the, here all the terms are the number of bricks. Okay, so here minus 14, which is not possible. Now let's take n is equal to 16. Then if n is equal to 16, A 16 is equal to A plus, that is first term, plus n minus 1, that is 15, okay, into minus 1, that is 30 minus 15, that is equal to 50. Okay, we have got 50. That is here, what is the answer? In how many rows? That is value of n. In how many rows? Okay, that is how many terms. So n is equal to 16, and how many bricks are there in the top row? That is, what is the last term? Okay, what is the last term? That is 15. Okay, so here we can write, and an is equal to 50. Okay, or we can write A 16 is equal to 50. That is, there are how many rows? 16 rows. Okay, there are 16 rows, and there are 15 bricks in the top row. There are 16 rows and there are 15 bricks in the top row.